how do we learn the probabilities that we need for the naive Bayes classifier? The simplest thing we could do is just to use maximum likelihood estimates. In other words, we just use the frequencies in the data. So we say our estimate, let's say, of the prior probability of a class J, is n, I'll use n to mean count, just the count of times that our class is class J over all documents. In other words, out of all documents, how many of them are class J? That's our prior probability of class J. And for the likelihood, we want to know how likely a feature, a particular feature or word is given a class. We'll just say out of all documents with a particular class, in those documents, how often did we see this particular feature occurring with that class? Looking specifically at words, we're going to estimate the likelihood, the probability of a given word given a class, by looking at the fraction of times that word occurs among all the words in the document that are of that class. So it's kind of a relative frequency. Out of every word that occurred in some document of class J, how many of those words, what percentage of those words were the word W that I'm looking at? That's the probability of W given C sub J. In other words, we're creating a kind of a meta document for a topic. We're going to concatenate every document that has that particular topic or class. So let's say we're doing sentiment analysis. We'll take all of the positive documents, concatenate them together, and create a big meta document called document pos. And we'll create a big meta document called document neg. So two big documents. And now we just count in each of those documents how often a particular word occurs and divide it by the total number of words. And that's our likelihood. That's our probability of a word given a class. So it's the frequency of the word in this meta document. Unfortunately, there's a problem with this simple maximum likelihood approach. And the problem has to do with zeros, the same problem that we saw in language modeling. What happens if a particular word, let's say it's the word fantastic, never occurs in our training documents in a particular topic, let's say in the topic positive, the thumbs up class. So we have two classes, thumbs up and thumbs down, or positive and negative. The word fantastic never appears in the training set. So that means the likelihood of that particular feature, X, fantastic, given the positive class, which we're going to compute by counting how many times fantastic occurred in the positive documents in our training set, that probability is 0. But the maximum likelihood class, the way we compute that is by multiplying together all the probabilities for each feature. And if any one of these probabilities is 0, the entire probability will be 0. And we'll never pick that class. So as soon as we see one unknown word, all of a sudden our naive Bayes classifier using the maximum likelihood estimates will fail. As you might expect, the solution for zeros is smoothing. And in text classification, the simplest smoothing algorithm is Laplace or add one smoothing. So again, all we're going to do with add one smoothing is we're going to take our maximum likelihood counts, we're going to add 1 to each count, we're going to add k, the number of values, to the denominator because we've added 1 each time. Or in text, that's like saying we're adding 1 to each count of each word in the class, and then we're adding to the denominator, the total count, we're going to add v to make up for each of the ones we've added for each word. We're adding 1 for each word, so we're adding the vocabulary size into the denominator. So let's look at the final multinomial naive Bayes learning algorithm. From the training corpus, we first extract a vocabulary, and we calculate, as we've shown you on the previous slide, the prior probability for each of the classes. And we do this by saying for every class in the set of classes, we create a metadoc sub j for each class j that just combines all the docs that have that class. We create our metadoc for each class. And now the probability of the class is just the number of documents in that class over the total number of documents. So of all the documents, how many fell into this class? That's the prior probability of the class. And then to calculate the likelihood term, P of W given C, where similarly we're going to take all of the documents in class J, concatenate them into one large document. And now for each word in our vocabulary that we've computed already, we're going to count the number of times that that word occurs in our meta document. And then the probability, the likelihood of the word given the class is just the add 1 or add alpha smoothed version of the maximum likelihood estimator. It's the number of times the word occurs divided by the count of all words with a little add 1 smoothing. And that's our basic algorithm for learning the naive Bayes parameters.